This quick tip video will highlight area rules in Path Professional. To get started with area rules, we need to open the Constraint Editor system. You can do this in either the schematic or the layout tool. For our example here, we'll be using the Paths Professional layout. To open Constraint Manager, you go up to the main toolbar, click on Constraint Manager icon. Once open, you're presented with the spreadsheet view of our design rules. First, we'll review the master scheme. The master scheme is the design rules for everything on the design. We already have net classes and clearance groups created. To create a rule area, we just need to create a new scheme. To do this, right-click over Schemes, choose New, type in the name for your scheme, because you'll be using that later to assign to a shape. Once completed, we can then expand out the new rule area and see that we have all the same net classes and clearance groups. Now that we have our scheme created, we'll go ahead and modify some design rules for our DDR nets within this new scheme. So we'll click on DDR. We're going to modify the trace width to 3 because we have less space to route inside the BGA area. This is very simple to do. You just click on the top cell, type in 3, and it will fill in 3 for every single net class that's listed. Now, if you want to be more specific to the individual groups, then you can do it just by individual subgroup instead of the master DDR class. Next, we'll adjust the differential pair spacing. We'll bring that down to 3 as well. Again, for spacing requirements inside the BGA, impedance isn't quite as critical because the distances run is very short. Next, we'll go down to the clearance section and make a design rule change. Notice the exact same clearance classes that were in the master scheme are also in the BGA DDR scheme. To show everything transferred over, we'll go ahead and click on the class to class icon, open that dialog box to see that all of the exact same class to class assignments are still available in our new BGA scheme. The convenience here is that I don't have to create individual clearance schemes for my area rule. They're all the exact same as the default scheme, and if anything gets added even at the default scheme, it automatically shows up for the BGA scheme as well, minimizing the amount of rules that I have to deal with. So to make an adjustment for our BGA area, let's use the power group I created, and we'll see that all the clearances are set to 10. That's far too wide for our BGA area. So we'll go ahead and set all those to 3. We can simply click on one of the cells, type in 3, and it'll fill in all the rows, and then you can use the drag function to pull it over across all the columns, just like you do in Excel. Next, we'll set specific via types that we're going to use within the BGA scheme. So to do this, we'll click back on one of the classes underneath the BGA DDR group. When you click on the little ellipse button in the via assignment section, you'll get a dialog box with all the blind and buried vias and through-hole types that have currently been defined in the database. And then from there, you can choose which ones are going to be used. We can just leave the default, knowing that when we set this up, there was only one via type to be used for that blind or buried via. If there are multiples, though, you can choose the pad stack definition. In the case of through-hole, we don't want to allow any through-hole vias within the BGA area, so I can turn that off and click OK. And now that will be adhered to by everything within the DDR master group. Now that we're done creating the rules, let's go ahead and create our rule area. To do this, we go to the Draw menu and choose Area Rule. We then select the type of shape we want to draw from the Draw Edit toolbar. In this case, we're just going to draw a simple square. After completed, a Properties dialog box will appear. From this dialog box, you'll choose the layers that the new rule area applies to. In this case, it's already set to all. We're just going to go ahead and leave that. And second, you just need to set the scheme that's going to be used. Normally this would be defaulted to master. In this case, we're going to set it to BGA DDR that we just created. Note, you can create as many rule areas within the design as you like, and you can even nest them inside of each other. Next, we'll go ahead and fan out the pins of this BGA. So we just grab all the pins, do right click, apply fan outs, and you'll see that it fanned out all of the pins in the BGA. If we zoom in here a little closer, you can see where it added the 1-2 via on pins and the through-hole pin vias. Next, because many of our DDR signals need to go down into layers 3, 4, 6, we're going to have to use the core via that we defined. So to do that, we can simply click on a pin, do Add Via. From the Add Via dialog box that appears, we can choose the appropriate pad stack that we've set up in our library for our 2.9 via, to which the tool should automatically set the layer span. In this case it did, 2.9. Now that we've done that, we can go ahead and drop this new via on top of the pin that we just selected, and it will create a 1.9 via for us using stacked vias. Many of the other pins in this BGA also need to have 1 to 9 vias. So to prevent me from having to use this add via function repeatedly, I can simply group select the via stack I just made and then copy it and paste it onto all the appropriate pins. Now moving on to routing, we can start routing some of our nets. We'll show the example of using the rule area here by using our interactive router. So as I click on one of the vias, you'll notice it also pulls out the other trace with it, which in this case was a differential pair setup. And as I cross that boundary, you will see the rules change instantly based on the scheme assignments that we just created. Pulling out a few more single-ended nets, you'll see the same thing. After routing a couple nets, let's see what happens when we do some trace modifications. So you'll see as I move this differential pair that the proper trace width and gap spacing is maintained regardless of the angle that it enters or exits the rule area. The same goes for all of our single-ended nets. As we push and shove those around, the proper trace and space is maintained as well.